Okay, so in this question, it's asking us what is the mass of 0.25 moles of CaCl2. Okay, so this is going to be a dimensional analysis problem, so we're going to be looking for our given, and we're going to be looking for our end. Now, the given is very easy. It just gives us a number and moles, so 0.25 moles. So we're going to do 0.25 moles, but we have to be very specific. Moles of CaCl2. So our given is moles of CaCl2. Our end, the thing that we're looking for, is what is the mass. Okay, whenever you see the word mass, when you're looking for mass in chemistry, you're usually going to be looking for grams. So what we're trying to figure out here is we're trying to figure out how many grams does 0.25 moles of CaCl2 weigh. Okay, so what we're going to do is the same thing we normally do for dimensional analysis. We're just going to write down our given number, so 0.25 moles of CaCl2, and then we're going to set up a fraction. For our fraction, we're going to try to get rid of moles of CaCl2, so we're going to put moles of CaCl2 on the bottom. So that way we can cross them out and get rid of them. And what we're looking for is grams. So we're looking for grams of CaCl2. Okay, we're looking for grams of CaCl2. So we have a fraction here. In order to solve this problem, we need to figure out how many grams per how many moles of CaCl2 there are. So what we need to do is make sure they're equal to each other. Okay, luckily for us, we have the formula. We know that this molecule is CaCl2. So we can actually write an equation and find this fraction using the molar mass. So if we have CaCl2, we know that CaCl2 is made out of 1 Ca, it's made out of 1 calcium, and it's made out of 2 chlorines, right? Because CaCl2. Okay, if we look on the periodic table, we can see that Ca, calcium, has a molar mass of 40.08. So we know that is 40.08 grams per mole. Right? This kind of looks like our fraction, grams per mole, grams over mole. Okay, Cl has the molar mass 35.45 grams per mole. But there are 2 of them, so we need to multiply this by 2. This one will multiply by 1. So if we do 40.08 times 1, it's 40.08 grams per mole. We know that Cl is 35.45, so what we're going to do is we're going to multiply it by 2. 35.45 times 2, 70.9 grams per mole. And since we're looking for them combined, we're just going to add them up. And so we'll do 70.9 plus 40.08, and that'll give us a molar mass of 110.98 grams per mole. Okay, what this tells us is that, remember, 1 mole of CaCl2 equals 110.98 grams of CaCl2. This is basically what the molar mass tells us. The molar mass lets us write an equation. It teaches us that 1 mole of that chemical has a mass of 110.98 grams. So what we can do is we can take this molar mass and plug it in to this fraction. It's an equation just like we did when we did normal dimensional analysis. So on the bottom we have moles, right? And the number in front of moles is 1. So what we're going to do is we're going to put 1 on the bottom of the fraction because it's 1 mole. We just need to put the number next to the unit. On the top we have grams, and so for grams we need to put the number in front of grams, which is 110.98. So on the top we're going to put 110.98, and there you go, we have the fraction completed. So the moles are going to cancel with each other, and on the top all we're going to have left is grams, so that's exactly what we're looking for. So all we need to do is calculate this out. So we just multiply the tops, divide by the bottom. So on the top we have 0.25, times 110.98, and that'll give us a final answer of 27.745. So our final answer is 27.745, and our units of measurement is grams of CaCl2. Okay, and there you go. That's exactly what you're looking for. What is the mass of 0.25 moles of CaCl2? It's going to be 27.745 grams of CaCl2. Okay, so we have one final example. If you feel pretty confident trying this on your own, feel free to pause the video and do so. But if not, it's okay. I'm going to go through it step by step. Okay, so in this problem, we are going to be talking about my favorite molecule. It's, I think, God's greatest gift to man. It's a stimulant with literally like no side effects. It's caffeine. Okay, so the question says, my morning coffee, it usually contains 0.5 grams of God's greatest gift to man, which is the molecule caffeine. How many moles of caffeine are in Mr. O's morning coffee? So since it's a dimensional analysis problem, we need to look for the given, and we want to look for the end. So the given is going to be the number. So we have 0.5 grams. So we're going to start off with 0.5 grams of caffeine, and then we're looking for how many, what? Moles. We're looking for moles. So we want to end up with moles. And I usually abbreviate moles with just MOL because the E is kind of hard to write, so we just keep it like that. Okay, so we're going to start with our given. Just like every dimensional analysis problem, we just write down 0.5 grams, and we're talking about caffeine, C8H10N4O2. So I'm going to write that formula down just so we're clear on what we're talking about. C8H10N4O2. We're going to set up a fraction. I want to get rid of grams, right? So I'm going to put grams on the bottom. And we want to end up with moles, okay? But we're talking about caffeine, so I'm going to be more specific. I'm going to write down the entire formula just so I can keep everything in order. Okay, so we have grams on the top and the bottom, so these can cancel out once we are able to solve our problem. And we're looking for moles, so I know I set up my fraction properly. Okay, all we need to do now is solve it out. Okay, so now we need to fill in the numbers for this fraction. So since we have grams and moles in the same fraction, that means we need to use molar mass. So whenever you see grams and moles on the same fraction, just know you're going to use molar mass. Okay, so what we're going to do is we're going to find the molar mass of this chemical right here for caffeine. We're going to find the molar mass of C8H10N4O2. And if you feel confident doing this part, you can pause the video here and try finding the molar mass for caffeine. Okay, but caffeine is made out of how many carbons? It's made out of 8 carbons. So it's 8 carbons. There's 10 hydrogens. There's 4 nitrogens, and there's 2 oxygens. And so what we're going to do here is we're just going to go on the periodic table, look for carbon. Carbon is 12.01, so we have 12.01, and there's 8 of them, so we're going to multiply that by 8. If we go on the periodic table, look for hydrogen. Hydrogen is 1.01. But since it's close to 1, we'll just keep it 1. So 1, and there's 10 of them times 10. I'm actually going to erase the 0.01 from carbon because it's very close to 12. If it's 0.01 on the periodic table, guys, you can just round it down. But if it's something like 0.07, you got to keep the 0.07. For nitrogen, nitrogen is 14.01. Again, it's 0.01, so we're going to drop the 0.01. So we have 14 times 4. And then we have oxygen. Oxygen is 16.0, so we're just going to write 16, and then we're going to multiply that by 2. Okay. So just to repeat myself, carbon, each carbon is 12 grams per mole, and we have 8 of them, so we do 12 times 8. 12 times 8. That's going to give us 96 grams per mole. Hydrogen is 1 each, and there's 10 of them, so it's going to be 10 grams per mole. For nitrogen, there's 4 of them, and each one is 14, so 14 times 4 is 56 grams per mole. And then for oxygen, each of them is 16, and there's 2 of them, so that's going to be 32 grams per mole. So if we wanted to find the molar mass of caffeine when they're all combined, all we need to do is just add them all up together. So we're just going to go on our calculator and punch in 96 plus 10 plus 56 plus 32. And so we find out that caffeine is going to be 194 grams per mole. This means that if I have 1 mole of caffeine, it's going to weigh 194 grams. So this is going to be our equation, and what we can do is use this equation to plug it into this fraction. So the number next to moles is 1. So we're going to put 1 on the top because that's where moles is. And the number next to grams is 194, so we're going to put 194 on the bottom. Okay, so now all we need to do is cancel out the grams. So we're going to cancel out grams. And all we have left over are moles, so we can just solve out this problem. So we can go on our calculator, multiply the tops, 0.5. We don't need to multiply by 1 because 0.5 times 1 is 0.5. And then divide by the bottom. So 0.5 divided by 194 is going to be this number right here. Now remember, guys, you have to give me 3 numbers after the decimal. But if there are zeros, you need to give me 3 non-zero numbers. So you're not going to write 0.002. You're going to write 0.00257. If you want to round that up to 8, that's fine, but you have to give me at least this much. You need to give me 3 non-zero numbers after the decimal point. So our answer here is going to be 0.00257, and our unit of measurement is going to be moles of caffeine, which is C8 H10 and 4O2, and this is going to be our final answer. Okay, so what this tells us is inside my morning coffee there are 0.00257 moles of caffeine. Alrighty guys, so hopefully that was helpful. I know that was a lot of new information. If you guys have any questions, make sure you guys let me know. I'm in the Zoom call to help you guys out. Good luck on your assignment, guys, and we'll see you next time.